Welcome back for another episode of Science Like Me, where we explore the scientific and career journey of our fabulous guest scientists. I'm your host, Saura Naderi. I have an engineering background here at UC San Diego, and I am currently working to broaden participation at the Halegiolu Data Science Institute. Today, I have the pleasure of talking with Ramesh Rao. He is the director of the Qualcomm Institute, better known as QI, the UC San Diego division of the California Institute for Telecommunications and Information Technology. I did it. It's a long one. CalIT2. There is a longer list of titles describing him. Professor, PhD in electrical and computer engineering, just to name a couple. Today, we are going to journey through understanding the current role that Ramesh has as director of QI, how that experience is going to shape the future of UCSD's newest venture, UC San Diego at Park and Market, and what his childhood was like that helped him get there. I also want to share that my first job out of the Jacobs School of Engineering was at QI, and it's the place that Ramesh allowed me to experiment in building my first outreach program. Really, Ramesh, you have a huge part in shaping and pivoting my career in this direction. So thank you and welcome.
Thank you, Saura. It's been wonderful to watch you evolve, start with these new ideas that you came up with, and it has gone so many places. After UCSD, you went to Qualcomm, then you came back to UCSD. We're delighted that you did that. So looking forward very much to responding to your prompts and sharing my story and how it might possibly help others understand the kinds of journeys we all undertake, when we are young and we finally get to where we are.
Yeah, thank you. So, I haven't seen you in actually over a little bit of a year, so I did want to briefly just see, how have you been? How has COVID affected you? Are you back on campus?
Yes, so I spend half a day every day on campus now, but like everybody else, pandemic had a huge effect on me. I taught a class last spring entirely online. It was a crazy exercise because I was debugging the tech and the platforms even as I was preparing the lectures and delivering the lectures. I cleaned every corner of the house that I had neglected for 20 years, crawled all the way up into the attic and vacuumed the attic. So I think I came to terms with the home, its layout, its orientation, where does the sun rise and where does it set. But I also discovered that we gain so much by interacting with others, and we miss that, even if it is not very explicit. We discover the value of these in-person interactions that we've gotten so accustomed to. So I'm enjoying coming into work half a day, every day, and I enjoy the efficiency of doing what I can do from my home before I get to the workplace. I hope you've been keeping well too, Saura.
Yeah.
I'm sure every one of us has gone through an interesting experience ourselves.
Yeah, I'm still working remotely. I'm actually not planning on coming in for another couple months. But you're right. Even just orienting the house in terms of how this, Zoom video is going to land and what my background is, it's funny how we have to pay attention to those things. And just the nature of how we interact via video. How do I try to compensate by and building these human connections without being in person? And those kinds of skill sets. It is hard. I also taught, actually. I was on the side teaching a high school class, and it was extremely difficult. It definitely is not my, I think I'm just very animated in real life, and so I feel like that was cut a little bit with the camera. So yeah, I feel you with the trying to teach a class through Zoom or some sort of platform like that.
I like to sort of kid around that if you're a teacher and you've been teaching for a long time, you become a stage actor. The classroom, the front of the classroom is your stage, and you take full advantage of that stage. And then all of a sudden, we have to become movie actors, learn to project by staring at a camera, which is invisible, and there's nothing behind it. So I think we've all adapted. But I think, although we'll probably never go back to being exactly the way we were, I feel very optimistic that the in-person encounters will be even more valued and even more cherished now that we know what it feels like not to have it.
Yeah, I do have hope for that same reason, that we just have more gratitude or more appreciation for those interactions, right? I think at least I took it for granted. how much it meant. And I think I would classify myself as pretty like surprisingly a recluse in a lot of ways. And so when it's forced that I cannot see people, then it was just like, wait a second. I definitely like the choice. So anyways, you know, you said something actually, even just in catching up, the fact that you're teaching yet another role. I mean, how many hats do you actually have on campus?
You know, so I'm a professor in electrical and computer engineering department. I do teach courses, and this course that I was teaching is a sort of a basics course, stochastic processes, but it took on special meaning because, you know, I think part of what you have to learn to do during the pandemic is to learn with probabilistic information. You know, there are no hard answers to will a mask protect you or not protect you, and will a vaccine protect you or not. So I took advantage of this opportunity to reflect a little bit on how people use uncertain information to plan their lives. So on the one hand, it is a very standard course. On the other hand, I think it took on special meaning.
So I love that you're a scientist at heart, because even through this entire experience, you're also trying to look at it through the lens of you know, a question, and how do you analyze that question through the data that you're actually, you know, gathering, whether that's through observations or actually, you know, quantifying it or collecting it. So let's go into these prompts. These I'm going to rewind. We're going to go back into the past, and we're going to try to understand what you were like as little Ramesh. And I love saying that for some reason. What was little Ramesh like? Where did you grow up?
Yeah, so that's a lovely term because it helps me float out of my adult self and become a child again. So I grew up in a small company town about 100 kilometers from Calcutta, but it was in the middle of nowhere. It had been carved out because the government of India had set up its first fertilizer factory. So it was carved out of forests, I guess, forested land, and it was a beautiful little town. Everything was spick and span. I was born there. I went to school there. I grew up there. And it was a melting pot. You know, there are people from all parts of India. So practically everybody on the street I grew up in spoke a different language.
Oh, wow.
So you learned early on lived experience of diverse cultures, diverse lifestyles, diverse values. And you celebrated it. You know, it wasn't just being aware of it, but actually benefiting from it. So that's where I grew up. Everybody that worked in that town worked in that particular factory, and so we were surrounded by lots of engineers and lots of technical people. Most of them were chemical engineers. My dad worked as a process engineer, and for some reason he was very deeply interested in his own way in pedagogy and different approaches to teaching. So he would never leave us alone. You know, what we were being taught in schools was never good enough for him. So he was always finding books from around the world, trying to keep up with the most modern ways in which people were educating the young ones. And we were his subjects, you know. So me and my brother got to experience not only the standard curriculum, but all these new things that he would come up with and put us through our paces.
How many, you said there are so many different languages. How many languages do you think did you know by the time you were, I don't know, 17?
5.
Jeez. Yeah. Wow. What? Sorry, I didn't mean to that's a lot.
So, you know, it's a funny thing. Many Indians do have this sort of experience. My home, there were 4 languages that were spoken every single day. So it wasn't just like you heard it on the street. And I reserved a certain language for each member of my family. I spoke Marathi with my mother. I spoke English with my dad. I spoke Hindi with my brother. And we would never mix these languages. You know, it's sort of like you settle into a pattern. And my parents would speak to each other in Tamil. That was the secret language. They thought we couldn't follow Tamil. So when mom had something to complain about, she would complain in Tamil. So that's how we figured out Tamil, because we knew what we had done wrong. And so when you heard them communicate, that's how you learned. So you also learn that it's not just languages, it's also sensibilities, it's how you express things. There are certain things which are very easily conveyed in certain languages and not so easily conveyed in certain other languages. That's part of the appreciation of the richness of these influences.
Yeah, I only know 2 languages, and I did feel like there were certain times, there were concepts I couldn't communicate in English that I could communicate in Farsi. And so I can appreciate, I mean, 5 languages, that's even better. Just the sense of appreciation of just concepts alone, like you said, sensibilities. How do you communicate that? Did you ever, I mean, you didn't mix them, but were there times where you're like, you did try to use a word from another one to just kind of help communicate that with your brother, let's say?
Yes, no, you absolutely do that. In fact, there is an art to mixing 2 languages, and so people are very good at this.
Yeah.
So you almost invent one of your own. No, absolutely. And when we had to make the most precise arguments and argue our way through, we always did that in English.
Nice. So, I mean, you kind of went through, like, when did you know you wanted to pursue engineering? I mean, your dad shared it with you, but did you ever resist?
No, so actually it's a much more personal experience. So I didn't get to share that more playful awakening, if you wish. We had one bicycle in the home that Dad would ride to work and back, and me and my brother would wait at the end of the day for him to come back so we could, grab the bike and go see our friends. And we would repair the bike. I got good enough at it that sometimes when he came home at lunchtime, I would take the front wheel apart, grease the ball bearings, and put it back together. Now, these bikes were like ancient British bikes. They're not designed to be modular and easy to fix. So you really had to know what you were doing. Otherwise, you would lose a little ball bearing, and then the thing wouldn't be the same. And you would get into trouble if you did that. So I thought I got quite good fixing bikes. But then one day, my uncle, who used to live with us, said, you know what? Really, the future is electronics. It's not mechanical engineering. And so even though I was feeling really good about being able to do these things, mechanical things, I said, what is that, And let's learn a little bit more about it. And, I don't know if you've heard me tell these stories, but electricity was this fascinating, magical thing. It's completely invisible. But you can put it to work, and if you don't know how to deal with it, it can kill you. So there was this sense of mastery, if only you learned how things worked. And so it was seductive, it was fascinating. And my dad taught me, lots of little memories like this, how to change the fuse in the house when the fuse blew. Now, these days, we have circuit breakers. We just flip them, right, when they get set off. But back in the day, we would have this big, fat, porcelain tab-like things. You pulled it out, and you actually wired it with this fuse wire. And you had to pick the right one so you wouldn't put in the wrong one and perhaps create an electrical hazard. But in any case, I learned to replace the fuse in the house when I was about 6. And I really felt like I was a grown-up. When the lights went out for some reason and Mom needed help, I could replace the fuse. That was my first-hand experience with taming electricity. And I think that was just the beginning. And so electrical engineering and electronics, communications, radios, these things were the most magical things that we grew up with. And that was just so fascinating. I never quit.
I can't emphasize enough for viewers, really, that how important it is to just play, right? To get your hands dirty with these things. You were changing these fuses, but did you know why it was working the way it was? I mean, that came later, probably, right?
No, so because I felt really good about being able to change the fuse, I would sometimes purposely set up a short circuit, or take a piece of wire and turn it on. The fuse would blow, and then, I was your man to help fix things up. So I understood, voltages and currents and the heat that is generated when you have a high current flowing through a piece of wire, and how the nature of the material of the wire would determine how many amps it could take. And if you put 2 wires around it, you basically double the capacity, and so the fuse wouldn't blow. So you learned series combinations, parallel combinations by just changing the fuse in the house. No, but it also gave you a reason to learn. You wanted to master this. It wasn't just some corny thing, just wind enough of it and then it'll be okay, but maybe the house burns down. So it really made sense to then learn about physics, learn about electricity, learn about magnetism. One thing leads to another.
Yeah. I do have to say, I do think that there should be like a warning right now that says, please do not play with your circuits without parent supervision, and even then, maybe without a professional. Like, we do not take responsibility. Was there any time that something did go wrong? I mean,
well, the thing that would go wrong is, in India, it's 220 volts, 50 hertz, which is a higher voltage, and therefore, it stings more than it would in the US at 110. And we were constantly electrocuting ourselves inadvertently. And, it was kind of like one of those things you bragged about, oh, yeah, I can handle this. And that was scary in some ways, but you also learn to respect these things. There is a reason why you're asked to wear shoes. There is a reason why you have insulated pliers when you're working on electrical circuits. So it wasn't just arbitrary rules that were handed down to you. You knew what price you would pay if you didn't follow the rules.
I have to tell you, in spite of my, my training is in electrical engineering, I still actually I'm scared of using the clips for jumping the car. I mean, I know what I need to do in theory, but the idea of just like somehow, I don't know, if I feel like I'm going to do it wrong, I'm still terrified. So I think there is a healthy amount of fear to have around electronics. I'm curious, were there any barriers? And if so, what were they in your growth?
I was thinking about this, and I think many of the things that you've been doing, Saura, directly play into this. There's not a lot of experimentation that you could do. Honestly, other than playing with the fuse box, there was nothing else you could actually experimentally do. You couldn't really make a motor. You didn't get the materials that you needed. So educational kits. Dad found us one, and we were amongst the only people that we knew that actually had this kit that allowed you to actually make a motor if you wanted to, but even simpler things, relays and things of this sort. So basically accessible kits, educational kits that allow you to understand firsthand, how these things work, and in the process, learn it at a much deeper level than if you just studied it on paper. I also feel that some of these things are material things. You have to hold it in your hand to really get a sense of what these things look like and feel like. These days, we do more and more virtually, but I think it is important to have real material objects that you can play with. So making physical kits and mailing it out to people so they can, assemble things on their own, even if they're in isolation, I think is an important part of what we need to do.
I think this conversation just inspired an idea. I feel like there should be, from what you're sharing about your experiences, it seemed like there weren't so many distractions in terms of a TV or a million different options of what you could do. There was one bike, and so you played with that bike, you fixed that bike. There was a fuse that broke every once in a while. You learned how to do it so you can fix the house. I'm curious. I think it'd be cool if there was almost like an escape room experience in which an individual would have to experiment with electronics in some way or in some tangible way to get themselves out, or go to a camp that really reduces what they can do so that they can focus on these kinds of experiences, because it is very empowering, and it can then extend to right up to our age now, and make new games and make new devices. Having that fundamental knowledge is so valuable. But it's hard to motivate, I think, now because of the distractions.
Yes, at the same time, we all have material laying around in our homes that can be used to do some of these experiments. The telephone and the shortwave radio we had at home were also opportunities for me later on to play with. And with the radio, it was antennas. So you kind of understood the importance of having an antenna and the alignment, the orientation, and the location of the antenna, and how it picks up interference, and what does it take to pull in signals from thousands of miles away. So listening to the BBC was a big part of growing up, and having an antenna that would allow you to pull in signals being broadcast from London. Again, it's sort of magical thing. So you would go to great lengths to understand antenna design so that you had this opportunity.
I think also that maybe there should be some sort of worksheet along with this interview that says find these things in your home and make a little radio to talk to your neighbor. So, I'm also very curious about this because I know it was true for me. Did you ever want to give up on this path? Like, you're interested in electrical engineering. At what point did you say to yourself, "This is what I'm going to do"? And then once you started that path, was there ever a point that you say, "You know what? I don't really want to do this"? And if so, what helped you stay on it?
So, electrical engineering, I have been steadfast. I've never had any doubts. There was always something that I could do. But this isn't exactly what you're asking me. But I felt that way about athletics. So when I was a kid, went to a pretty decent school. There were some super athletes. But the way things were, it's only the super athletes that got attention and got advice and so on, and they became very good. The rest of us, you get dispirited because you just didn't know how to improve yourself. And so you kind of would want to give up, saying, this is not for me. I used to love to run, even as a teenager, but I gave up fairly quickly because it just wasn't working out. But later on, when I turned 50, I went back to it. And I feel it was partly just this mental desire that you kind of nurture in a strange way, that you want to be outdoors and you want to be running. Like I sometimes say, I've been running in my mind all my life, and now I run in the real world. And there are signs and understanding and devices to track your improvement, your progress, and real life coaches who can teach you techniques. All of that made a difference. So if you grow up in an environment in which you don't have that, then unless you're very good, it's very easy to get dispirited and give up. So I would say I gave up on any athletic sort of ambitions that I had as a kid. I run for fitness now, but somehow electrical engineering kept me going.
So I love that, actually. I mean, that absolutely applies. I feel like any pathway anyone goes down, if you feel like you're not good enough in it, or in that kind of, that whatever narrative you're telling yourself, it is easy to give up. But I love that you came back to it, and I love that you recognize that sometimes we need help to get back to it. So these sensors and techniques helped you stay on that path of revisiting it. I have to say, for me, exercising, actually, I'm in the same boat. I was not a very big fan of exercising. But I've only recently started weightlifting, which is so random. I never thought I would like it, for the last about year. And I love it. Like, mental health-wise, it's amazing. And I just wish I didn't tell myself that wasn't something I couldn't do. But I have to tell you, I love discovering it later. So even though it was a later thing, it is kind of cool to be like, hey, I'm actually in shape. I can go upstairs, and it's not that hard. Like, sure, it would have been nicer to do before, but whatever.
Yeah.
I think basically that mentality can be applied in so many avenues. So you can have an anchor here, but other things you might dismiss yourself on. So how do you remotivate yourself to try again?
I was talking to some colleagues. We have a Center for Healthy Aging, and there is a lot of systematic studies on how does one age well. And part of the understanding that has emerged is that you got to have a purpose in life after you retire. And nearly everybody now lives for, 20, 25 years post-retirement. So it's almost like people are saving up some new activities that they will want to pick up on after they retire. Learn a new language, learn to play a musical instrument, do things they never did until they retired. That gives you something to look forward to.
I have to share my dad. My dad's, he has one patent, and he did this at the very end of his career. It's some quantum computing piece. So he's also an electrical engineer. And in his retirement, decided to teach himself how to paint. So at 65 years old, at first it wasn't that great, but now it's amazing. And I'm just like, wow, don't ever think you can't learn a new skill later, because he is phenomenal. And he's got maybe 100 paintings right now.
Wow.
It's pretty cool. So let's now we went from the past, let's move to the current. And I want to understand, I have an understanding, but I want the audience to understand, what is it that you do at QI?
So, the beautiful thing about the Qualcomm Institute is how we combine multiple disciplines and we go after problems. that don't necessarily lend themselves to one discipline. There are some problems you can solve as just an electrical engineer and so on. But there are these interesting things that we are living through. The pandemic is a good example. It's just amazing how the whole world adapted. And in some cases, the economies have come out of it in better shape than they were going in. It's the combination of things. And so it's got its challenges and complexity because you're dealing with folks that come from different backgrounds, have different expectations. But the scholar in you will appreciate the value of understanding how different people approach the same thing. So the classic example, one of the early lessons I learned is the stark difference, and I'm purposely making it even starker, difference between how engineers look at life and how I think artists look at life. You see, I think an engineer likes to solve problems, okay? Creating a problem is not a good thing to do if you're an engineer. The purpose of life is to solve problems. I learned from talking to artists that they have the exact opposite perspective. They're like, what do you mean solve problems? Life is not a problem to be solved, and the purpose is, to some extent, to identify what are the big questions, what is the big problem of the time, right? You don't have to solve it. If you insist on solving the problems that you define, you will not define the really most important problems because you probably can't solve them. So being hooked on solving the problem limits your ability to define the problems that really matter. So from my point of view, artists are extremely good, disturbance theater and so on, to define a problem and walk away. They're not going to solve that problem. That's not what they set out to do. It's highlighting it, bringing it to your attention, and then you will figure out what to make of it. So now if you put the two together, you have a much richer environment, right? You define the best problems and you also find interesting ways in which you can solve them. So I think the biggest payoff for me at a very personal, intellectual level is just understanding how different communities define their objectives. How do they generate knowledge? What is legitimate knowledge in different disciplines, and what counts, and how do they build on it, and how do they produce impact? I think it's a very enriching experience. And I really miss this because of my hardcore engineering education, I think we will all benefit from being exposed to the ways in which many different disciplines work. And so, it's a privilege to be able to watch over a collection as diverse and wide-ranging as what we do at the Qualcomm Institute has been.
I love that. I remember that experience being there too, is the multidisciplinary nature of it. I also can't help but point out the fact that your childhood with cultural experiences and being able to appreciate everyone and almost like appreciate everybody, what they bring to the table, is almost what you're replaying right now as a director, right? You're appreciating all these different skill sets that might not be inherent to your own, but how do you help them thrive so that they can, make the best with each other? Which is so cool, right?
Yeah, it is. The other little trick I learned as a kid, which to this day works, so since you're picking up on it, I feel like elaborating, is that going back to my childhood days, if your next door neighbor spoke a completely different language, there was this question about, do they include you amongst themselves, or do they kind of hold you at arm's length because you're clearly not part of that community? What I found is that the role of the observer helps you embed yourself in lots of different spaces. You don't have to, so if you're just a respectful observer of what they do, they include you, and so I would find myself experiencing firsthand how people ate. Like, for example, in my household, you never eat out of a shared plate. Absolutely not. You would never do that. But the folks who lived next door, they ate out of one big shared plate, right? Very different experience. But they would invite me to partake of that meal, with the rest of them. So you learn, at a much deeper level, if you don't start out with a judgmental posture, we don't do this, we do that, this sort of stuff, but they admit you. So you can hang out with faculty or researchers from any discipline, and if you can learn to keep up with their way of thinking, they reveal more.
I want to put that on a bumper sticker, be a respectful observer. I think that's great, actually. How has your scientific background actually helped your current role?
So that's an interesting thing. For better or for worse, your brain gets molded by the topics that you learn and spend a lot of time studying. And so no matter what you're doing in life, you do bring some aspects of your core academic training to bear. So Saura, I know you're an electrical engineer. So I hope we don't get too nerdy here. But in many systems, there are two variables that help you understand how the system works. So in electrical systems, it's measuring voltages and measuring currents, right? So we design circuits that alter the relationship between voltages and currents, fans, bulbs, all kinds of other electrical appliances. But you design things, you debug things by measuring these two things. You have probes, you have ways in which to look at these and figure out what's going on. Out of the two, there is one variable that is easy to measure. Voltages are easy to measure, right? Because you don't have to cut the circuit to measure the voltage. You can easily stick a voltmeter and you can figure out the voltage difference. But if you want to measure the current flowing through a circuit, it's not easy. So there are not that many ammeters around. So if you want to think of a system, there is something that is easy to measure and something that is very difficult to measure unless you're in it, okay? So in mechanical systems, it is force and displacement. So if I move my hand, it's very easy for you to tell from where you are, how much my hand moved. But you don't know how much resistance I was going up against, in moving that, right? So understanding the force is harder, but understanding displacement is easy. So organizationally, there are some things that are very easy to measure. How many millions of dollars of grants did you bring in? It's very easy to measure that, right? You just look up the spreadsheet and you know the answer to that. What did it take to win that is very difficult to measure, right? Sometimes you can get $1 million without too much effort, and sometimes getting $100,000 is an immense amount of effort, right? So if you really want to understand how a system works, you have to recognize that there are some things which are easily measured, but you should not assume that just that measurement will reveal to you what it takes to do it. So at some level, I find myself, I'm not consciously saying voltages and currents, but when you look at how an area is doing and you can see some numbers, it's only the people who are in that area that can tell you what it means to change that number by 10% or 100% or 20%, right? So you have to figure that out. You have to figure out the Ohm's law for that area. How is voltage and current for that area related? And it's different in different areas.
I mean, it seems like it's the human factor. When you just said it, you have to feel it. It is hard to measure how much effort it's taking somebody, especially since we all have different ways of communicating what that looks like. So maybe for me, if I'm, too much effort, you'll see me pulling my hair, right? But for somebody else, it might look different. So even that is interesting. And so calibrating yourself and trying to figure out what does it look like for each of these, research groups or individuals. I mean, you're right. It is actually.
Right.
It's underestimated too.
If I have to come up with somewhat of an abstraction to explain this, it's like, what is the uncertainty you overcame? What did you not know when you set out to do this? And you overcame that by researching, by reading, by talking, by experimenting, by iterating, by prototyping, before you learn to go to that next step. So it's this uncertainty that you confront. How much uncertainty were you able to overcome? That, I think, is a real measure of success.
They say that grit is the number one measure of success. And I feel like in this case, as you are reiterating to try to solve a problem or whatever, identify a problem, not giving up is such a big piece because you don't know what that effort's going to look like. And that effort might look different, you trying this time versus you trying 10 years from now.
Very true. Very true. I agree. Yeah.
What is your approach to problem solving?
Many of the problems that I confront, given what I do, are hard to isolate. It takes place in a much larger context. It's kind of like, how do you change an ecosystem? So you have to understand many other things that have an impact on the issue that you're trying to confront. So you have to figure out what that larger context is in which something is taking place, so that you don't come up with solutions that actually might solve this problem but create two other problems that may be worse than the one that you solved. Right? So part of it is trying to understand these interconnections amongst the many different things. The university is very richly interconnected system. And picking out any two things and trying to make a difference to those two things sometimes will not be successful, because if you ignore many of these other connections, then it doesn't go very far. So reading the larger ecosystem, if you wish, learning about the collection of things that influence something. Let me give you an analogy which might be less theoretically stated. In an electrical circuit, we have clear inputs and clear outputs, right? Increase the voltage, the lamp lumens will go up, right? We understand this. But if you think of the human body, there's no obvious input and no obvious output. Let's talk about how much food we feel like eating and exercise. Which one is the input and which one is the output? If you work out hard, you can think of that as the input to your appetite. You will feel like eating more because you worked out. And if you've done any serious running or anything else for that matter, you know that how fast you can run, how long you can run depends on how much you ate. So is food the input to the running, or is running the input to the appetite? Both are true.
Right.
So you don't have a clean separation between inputs and outputs. They're all interconnected, right? So you're going into this interconnected world and trying to make a difference. You want to run faster. You want to run longer. What do you have to do? A whole bunch of things. You got to sleep right. You got to eat at the right time. You got to train over a long period of time. So it doesn't have a simple answer. Taking the time to learn what these interconnections might be, taking the time to recognize that sometimes the solution to a problem isn't immediately evident. It's not one of the two things that are coming together, but there is something else, like sleep. What improves your appetite and your athletic performance is sleep.
I really like that analogy, actually, because it does seem like initially would be straightforward, but it's not. I mean, there are so many other variables, and your individual body type probably factors into what kinds of foods can you eat. So that's really interesting, because I think even earlier you said about running, once you learn these techniques and you have these sensors that give you this feedback, you can optimize your ability to run. It's a great analogy.
And that is where the coach comes in, because the coach can tell you, knowing you and knowing how you're performing and what your objectives are, what should you do? So you need a human being to be able to guide you to reach different objectives that you might have.
And you said earlier too, it's not this easily measured thing. It's something that you feel out. So you also have to almost be patient with yourself to find those answers and what's right for you too. Which I think, at least for me, I'm very impatient. I think if I'm not doing something well immediately, maybe that's what I'm not supposed to do. But that is actually, I have found, fortunately, that that's not the right way to think, and that sometimes some things will take me longer than others to figure out, and I'm actually pretty good at it. But that's, I like that, because it's not obvious, right? Anything that is not obvious and actually helpful is interesting. So I think you've already shared this, but I'm going to ask the question anyway. How much of your current role is rooted in science versus administrative?
It's strange. One bleeds into the other.
Yeah.
Although you formally compartmentalize it, but things you learn in one affects. It's just the nature of your mind. You can't switch off portions of your mind, at will. So.
Yeah, I think like you said, like with the the ecosystem is really how these people are working together. It's part of the administrative, and then the science of how you kind of analyze this kind of comes into play. So, did you imagine that when you were setting out to get your PhD that you would be in this current role?
No, I had no idea. So, honestly, given the influences that shaped me, I think you can explain most of the things I've done in life with a simple rule. Whenever you come onto a fork in the road, take the one which is harder. Okay, just keep doing that.
Nice. It's scary, but nice. You're right. So let's now work into the future. So there is, there's a couple questions in here. So, what's next? I think what next for you? What's next for QI? How does your approach change when working on public serving projects? And then I really do want to actually get into the new building that's opening up on Park and Market. So UC San Diego's Park and Market. How is QI involved in that? So I don't know which one we should answer first.
So let's start with the first one, because it's a good example of something that I learned from hanging out with anthropologists like Professor Mike Cole. So if you want to go work in the community, it's a good idea to talk to the people who live in that community and learn from them, how they see life, how they see themselves taking advantage of new technologies. I'll be direct with you. I was a little bit reluctant to go into a community that is considered to be underserved, that is considered to be behind, and then talk about esoteric things like virtual reality and futuristic sounding stuff. But I learned from actually going into the community and talking to people that they are tired of people who show up, especially from academic institutions, who want to solve their problems. And start by asking them, what are your problems? Can you tell me what your problems are? I'll help you solve them. They don't want to have that conversation, right? They want to turn it around and say, tell us what's the coolest thing you are doing, and I'll find a way to take advantage of it in ways that adapt to my environment far better than you will be able to. But just give me access to this new tool. So give me the next new hammer. I know what to do with that hammer better than you can teach me, but I don't have that tool, so give me the tools. It's a good example, I think it makes sense in hindsight. So I think working in the community with people who live in the community, whose lived experience influences how they react to things, I think enriches us. So working in some of these projects requires us to get out there, get out of the lab, get out into the real world.
Yeah, I love the trend. I feel like that's something I've been hearing more and more of at UCSD is that is not trying to prescribe for other people how to solve their problems, but really inviting and opening the doors and saying, here's what we have. How is any of it, can you use any of it? Is any of it helpful? And building those relationships, actually, I found that was one of the bigger pieces too, it's just, again, I keep going back to your childhood. I just feel like your childhood is so relevant for your role right now. Like going to your neighbor's house and being a respectful observer, and not trying to judge how they share from the single plate. You join in, they lit you. I love it. It's all coming back. So let's dive into this Park and Market.
Yes, so the Park and Market is an amazing, to me, presents an amazing combination of things. First of all, both the physical and the metaphorical meaning of having a building downtown, which is so tightly coupled with the building up here on campus through the main Blue Line trolley stops that we have here, I think is just remarkable. Instead of having people come up to La Jolla to attend our events and drop in on our labs, now we can go into spaces that are much closer to where the community is. So I think it's just extraordinary, this connectivity. Many of the things that we've been doing at the Qualcomm Institute for many years actually lend themselves perfectly, from the point of view of sharing and restaging in the location downtown. So we have a gallery, an art gallery. We have 3 or 4 gallery shows. There are public-facing spaces in the first 2 floors of the UCSD Park and Market that lend themselves to public events. We've been working closely with Extension, with Mary Walshock, to have 2 big video walls, one outward-facing and one inward-facing. You can imagine programming all through the night. You don't even have to be inside the building. You can just stand outside and watch all this rich content, whether it is scientific expeditions and imagery from the bottom of the oceans or new forms of artistic expression. We do these things on campus, and it's largely accessible only to people who already are on campus. All of a sudden, you have this new audience that can drop in and take a look at it. So we have the Ideas Performance Series, we have the gallery. But for me, I have to say, being a wireless networking researcher, that location has special significance. I tell you why. It's kind of a nerdy thing, but there is a demand for more and more wireless communications, and so the FCC opens up new frequency bands. And there are these bands that have historically been set aside for the US Navy for use for its massive high-power radars, which they turn on when they are out at the high seas, not when they are at port. So this location that we have at Park and Market is within about a mile or so of the big Navy ships, about 2 miles from the San Diego airport. There is aviation radar that uses the frequencies. There is Navy radar that uses those frequencies. And now those same frequencies are going to be used for next generation wireless communication systems. So you see, it's kind of like a very interesting place where there are very different types of users that have to coexist. So it's a technically challenging problem, and we like to solve such problems. And that location is perfect for it. So we see it as a launching point for new kinds of novel wireless communication technologies that also addresses the digital inequities that perhaps affect some parts of our town, right? You want to truly reduce the cost of these technologies. So, not everybody needs to have a $100 a month data plan. Not because there is a discount being offered by somebody, but because the underlying technology itself became cheap, just like Wi-Fi. You can set up Wi-Fi at your home. You don't need to pay for a license to the FCC to do that. So technically, how do you innovate so that you reduce the cost and enhance the performance so that essentially you can connect more and more people and things in the environment?
How fun. Did you guys know that going in, that would be was that just like a side effect fun project?
It was a side effect and walking around the block kind of project. So we learned about Sherman Heights, which is a historic neighborhood in San Diego, beautiful homes, craftsman homes, but I think many of the people that lived in those neighborhoods have moved out to the suburbs, and it hasn't seen the renewal that some other parts of town see. But walking around, you begin to observe things about from a networking point of view. Sherman Heights is called Sherman Heights because it is up on a hill, which is a very good thing if you want to shoot a wireless link. So lighting up a neighborhood like that using these technologies actually happens more often than you might expect because of their location. And just walking around, you begin to see old infrastructure that is still there in the ground, whether it's old telephone exchanges, which can be put to use in new ways. So some of these old neighborhoods actually were designed for a different time, not as congested as some of the newer neighborhoods are. They're well laid out in many ways. So it lends itself to new technology deployment in new ways. So I think I'm being a little bit long-winded here, but walking around in the neighborhood actually gives you a lot of ideas on how you might take advantage of new technologies in those spaces.
Well, that's awesome. I mean, we love engineering, right? So we have time, like a nerdy playground, It's great. I think that answers the next question, actually. What happens at the intersection of research and public engagement? I mean, in this way, this kind of public engagement lended itself to trying to solve a wireless problem.
And one of the aspects, just like Wi-Fi, you can imagine more complex networks that can be owned by the people that live in the neighborhood, right? So community networks, as opposed to these highly expensive systems that companies like, Verizon, AT&T pay many billions of dollars to FCC to get the license to operate their systems. There are these frequency bands that are available, like Wi-Fi on campus here. As long as you know how to deploy the system, you can enjoy connectivity. So if you can teach people who live in those communities how to do this, how to create network in a box, and make it possible for people to learn and also decide for themselves, just like my fuse changing experience, it made me an electrical engineer. Somebody sets up their first networking thing in their home. Maybe they wake up and say, this is what I'm going to be doing. I'm going to learn how networks work. There's so much more magic in a network than a fuse blowing,
Yeah. It reminds me of when I was visiting Boulder, there was like this, on the edge of the city, somebody was describing to me what the neighbors did to get internet access, and I think they did something where they put these pieces together that were able to communicate with each other. And I remember thinking, at this time you would need to do something like that, but there are places that need that kind of support, and I think they took it upon themselves to be able to build that infrastructure. So you're right, it would be kind of cool to kind of have a, how-to kit with building your own network for your community. Another good idea. So what has the last 10 years of experience prepared you for what you envision for the downtown space?
So, these are like my personal cherished secret tools and techniques. You often run into many different groups. they all have something, but they don't have something, right? They're missing something, but they have a surplus of something else. If you can put the right group together, then they all serve each other, right? So you don't need a lot of resources as long as you put the right groups together. So there are folks that have new technology and they're dying to get it into more homes. There are community-based organizations that have the community organized and are looking for resources so that new initiatives can be activated. So if you have enough players coming together, it may not be two, it may be that you need a partnership with an alliance, 4 or 5 different groups. Then all of a sudden you find that you have everything you need to address the problem that you're trying to address.
Nice.
So that's the little secret. How does it happen? You never know. It depends on who you're talking to and what do they bring to the table, what do they want out of this conversation, and so on. But I think it's an even richer environment when you go downtown, the group of folks. So in the downtown building itself at the UCSD at Park and Market, we have so many other groups. The San Diego Workforce Partnership is there. The EDC is going to be there. The Black Chamber of Commerce is going to be there, literally in the building, right? So in terms of forming partnerships to do new things, many, a lot more promise.
What are you most excited about? I mean, it doesn't necessarily have to be Park and Market, anything. What are you most excited about?
At an abstract level, it is making an impact, right? So if you figure something out as an engineer, if you figure there is this knob that you can turn that really makes a difference, maybe to your health, okay? Maybe to the livelihoods of people who live in parts of town that have not seen any serious investment, So you're looking for this thing which is there in plain sight but overlooked, that if you can activate, it really makes an impact. So impactful work, that's the thing that keeps one excited.
Let's say somebody's watching this, they're like, I want to be involved in this Park and Market. I want to be involved in QI. How do community members be more involved? What parts of the community can be involved? And is it UCSD students? Is it prospective students? Is it K through 14 students, teachers, parents? Is there anyone that's not allowed?
Everybody is welcome. That's the obvious answer. But to answer your question at a slightly, to elaborate on it slightly more, most recently the state of California, big bonanza this year, amazingly enough, almost $1 billion one time, billion with a B, for UC to get caught up on all sorts of things like deferred maintenance. But one specific program that we were called upon to play is workforce training, okay? So trying to understand, going back to K through 12 segment, what should you be doing in 6th grade that prepares you to be able to participate in the economy that we expect will dominate the nation's future. So it's these pipelines. It's not about just what you do when you are already admitted into a department and you're in your 3rd year and you want to know what to do in your senior year, but these pathways. So there will be lots of events. There will be lots of points of engagement. I would welcome involvement from the community at any level. We do want to partner with schools which are in this business. We want to be able to connect with their teachers. I think you've been involved personally, working research experiences for students, for teachers. And not only STEM disciplines, but also the performing arts. So I personally believe that one way you can bridge these digital divides is through the performing arts, right? It's kind of a leveling thing. You see talent no matter where. So I think UCSD will be able to project its full breadth of expertise, technical, academic interests through this one location. It's a small location compared to the campus, but I think it can focus and create a showcase environment in which you can see all of this. So I think arts, technology, health, especially understanding about the social circumstances that we find ourselves in, the humanities, I think all of it will be showcased in that environment.
I'm excited. I'm really excited for this. I do see that it has a lot of potential, the impact of infusing the love of lifelong learning, really, and how do you set up anyone for any pathway that they want to get into, and how do we lend our expertise as an academic institution to anyone who's interested, which I think is absolutely lovely. We're actually, thank you for your time. Is there anything else that you wanted to share that you think we didn't cover?
So I should mention that as we spent time downtown, we learned of this wonderful new acoustic stage that has just been built called the Rady Shell at the Jacobs Park, at the Embarcadero. It's this beautiful acoustic space that has been recently designed with contributions from many philanthropists in the county. And we are engaged in discussions with the San Diego Symphony, actually, to see how we could create new kinds of augmented reality experiences. So your enjoyment of a performance doesn't have to be limited to the seat that you could afford to buy. You can wander in augmented reality space and get up there on the stage and stand right next to Yo-Yo Ma when he's performing and hear that acoustic experience that he has. The technology is there to do this today. So there's this beautiful stage. I'm told 85% is public use and 15% is ticketed use. So it's a nice place where people mingle. And I think it lends itself beautifully to applying many of the technologies that the Qualcomm Institute has been nurturing for the last 20 years. But pop it out in this much larger setting. So new streaming experiences, that's the future.
Well, Ramesh, this has been an awesome journey. I really appreciate your time taking me through the past, present, and future. Thank you, and I look forward to hearing more.
Thank you, Saura.